Good morning, and today we'll be looking at collinearity. Points are collinear if they lie on the same straight line. Now remember, the points that I'm referring to are coordinates. So coordinates are collinear if they lie on the same straight line. The coordinates, the points A, B and C are collinear, first of all, if we can work out that AB is parallel to BC. So we're going back to parallel vectors again. If AB turns out to be something times BC, where K is just a number, a scalar, then AB is parallel to BC. However, as we can see from the vectors that we've created, we have vector AB and vector BC. So if B is also a point common to both, which it is, then A, B and C are not just parallel, but they are actually collinear. They are actually the same straight line. So first question, prove that the points A, 2, 4, B, 8, 6 and C, 11, 7, these are three coordinates, prove that they are collinear. So let's create vectors using these points. Now there is another method that you can use for collinearity, and it's from the straight line topic. But we'll be using the vectors method for this today. And this is particularly useful when we have three-dimensional coordinates and that we're trying to prove that they are collinear. So this method is particularly good for three-dimensional coordinates. We're going to create the vector AB. Now remember, we did this the last day. The vector AB is B minus A. Okay, so it comes from the position vector B minus the position vector A. And we use the same numbers that we have for the coordinates. So 8 minus 2 and 6 minus 4 gives us the vector 6, 2. So to go from coordinate A to coordinate B, we will go along 6 and up 2. Then let's create the vector BC. C minus B. 11 minus 8. 7 minus 6. Now we have the vector 3, 1. So to go from B to C, we simply go along 3 and up 1. Now we want to try to see if these vectors are first of all parallel. Is one a multiple of the other? Now here we have a reminder of what AB is, which is 6, 2. And if you look at the top two numbers, can you say that this is something times this, or maybe a fraction of this? 6 is actually 2 times 3, and 2 is actually 2 times 1. So we can see that AB, which is 6, 2, is 2 times the second vector, which is 2 times BC. So AB is therefore 2 times BC. So that helps us to then be able to say that AB is parallel to BC. But we're not finished there. We have to put in the little fact that B is a point in common to both of the vectors AB and BC. So AB and C are collinear. So when we do these questions, we have to create the vectors. We have to say that one vector is a multiple of the other vector. It might be that one vector is a fraction of the other vector. We have to then make that statement and say that that means that one vector is parallel to the other vector. We have to look for the letter that's common to both and say that that letter is common to both, and that's what means that the coordinates A, B and C are collinear. So we need to see the word parallel and we need to see the word collinear at the end there, okay? So we want to show that one is a multiple of the other. That means they're parallel. B is a point in common to both, and that's what means that they are collinear. Okay? Here's a second part of the question. This is not always part of it, but it's very simple if it is. Let me show you how you would do this. Find the ratio of AB to BC. So what is the actual ratio of AB to BC? Now we've already worked out that AB is equal to 2 times BC, so we've already done that part of it. We know that AB equals 2 BC. So what that means then, if we bring the BC over to the left-hand side and make it a divide, AB divided by BC. Now there's lots of lines there, so that's just the vector AB there. That's the dividing line, and that's the vector BC there. So AB divided by BC is just 2. But if we write that right-hand side as a fraction, The number 2 is just the fraction 2 over 1, isn't it? So AB over BC equals 2 over 1. So that means that the ratio AB to BC is 2 to 1 in that order. Okay, and that's us. So now we can have a look at exercise 13I. Questions 1, A and C, and then 2 to 5, and also some three-dimensional coordinates in exercise 13N, questions 15, 16 and 18. And as always, message your teacher if you have any questions and send in your marked work to get checked by your teacher. Okay, good luck with everything and take care. Bye-bye.